So hi everyone, and welcome to the first community call in 2022. I hope everyone had a wonderful new year. Today we're going to have an agenda. Today's agenda, we're going to look through a number of different topics that have been submitted. Mukundan is going to kick it off looking at the new Azure Event Hubs PubSub component. After that, Dimitri is going to show a POC, a proof of concept of how you're querying the Redis state store. In previous community meetings, you'll have seen we showed demos of the querying state store on top of MongoDB. And so he's now showing an implementation on a different state store. Jeroen will lead a discussion on pluggable gRPC components and how that will bring in a range of different types of developers who can build components. And as always, we finish up with an open discussion where you can feel free to post your own questions in the chat window, or we'll take you off your mic and you can ask them that way. So with that, I will hand it over to Mukundan. I will stop sharing and Mukundan will take us off on the first topic of the Azure Event Hubs PubSub component. So Mukundan.
Hello.
Hello.
Yeah. Hello, Mark. I hope you are able to see my screen. So
yes.
I'm going to start with the Azure Event Hubs PubSub component. It's essentially a rewrite of the existing Azure Event Hubs component because there were some issues that were there with the current Event Hubs component that's there in till 1.5. So the existing issues are basically you can only connect to a given single event hub via the connection string. So all of the other PubSub components allow you to connect to, let's say if it's a Kafka, you can connect to the broker, you can publish to multiple topics and so on. But that is not possible with via the existing component. You just connect to a single event hub and the topic fields in the incoming requests for both publish and subscribe are not directly honored. They're just like not used at all, right? So the other one is there's no partition key support for publish. So what happens is enabling partition key support in event hubs also guarantees in order processing. That's by design of event hubs. It also guarantees in order processing. So that was missing. The other one is Event Hub's entity management support is missing. So if you have used Azure Service Bus component in Dapr before, Azure Service Bus component has ability to create topics on the fly as long as it has the permissions defined for it. So that was missing in Event Hubs. And then it only supports a single a bug that is there is basically it only supports a single subscriber to a given topic. So and then all the other Azure AD I mean the components that we have started including Azure AAD support based on, let's say, client secrets, certificates, and MSI. So that support is not available with the existing component. So what are all the features or fixes that have been done for this is essentially support for connection via the event hub namespace connection string. So you directly connect to the event hub namespace, and from there, based on the incoming request field for topic, you can connect to different event hubs, right? So and then support for publishing to different event hubs. That's part of the previous one, and also based on alternate authentication mechanisms. And then support for partition key metadata, which enables in-order processing. And then support for multiple subscribers reading from a given topic. So that was a bug fix that was done. And support for entity management. Currently, this is only possible through the Azure AAD authentication and not through connection strings. That is by default how event hubs work. It needs AAD authentication for entity management support based on the management libraries that are being used. So in the entity management, you can basically create event hubs in a given namespace if it does not exist. And again, creation of consumer groups for a given subscription or to an event hub namespace, again, if it does not exist. And then support for alternate authentication mechanisms like client credentials, client certificates and MSI. Right. So these are the new features or fixes that have been added for this component. So let's quickly dive into a demo where I'll be showing what are the new fields that are there in the component configuration template. And then I'll be showing a demo on multiple subscribers subscribing to a given topic with multiple partitions. And then a demo on publishing to multiple topics. And if there is time, there's also a demo for subscribing to multiple subscribers subscribing to a given one single topic, right? So the topics that I'll be using, let's start with the first initial discussion, which is basically the template. So previously the template only had the connection string, which is basically the event hub connection string. And then you would have the storage account key, name, and storage container, which is needed for subscription, right? For adding checkpoints and so on. So now the support has been added with backwards compatibility to basically add connection string without the entity path here. So it is basically going to connect to the event hub namespace. So that's possible. And then another field called event hub namespace is added. This will be used only when AAD or MSI based connection is there. Because in that scenario, I just quickly share my screen regarding that. So you would only have, let's say, you would basically define Azure tenant ID, Azure client ID, and Azure client secret as for a client secret based authentication. So in that scenario, or if you want to have a client certificate file, you would also need to know which event hub namespace you're connecting to. So that is where this event hub namespace field is used. And similarly, this storage account name, storage account key, and storage container name, that's only currently needed for subscribers. If the app is going to subscribe to a given topic or so, then you would need these fields. And then the other one that's there is enabling entity management. Only if enable entity management field is true, by default it is false. Only if it is true, you would need these fields, which are basically you would need to specify what is the message retention in days for the newly created event hub, or what is the partition count it's going to be, and what's the subscription ID for the Azure subscription that you have, and also the resource group name in which the event hub namespace needs to be created. So these are some fields that have been added as part of this one, right? So then the other one that I want to show you is kind of a simple app. I've just modified the quick starts here just to show that how the subscribers work and how publish works. I'm using two different topics that are going to be here. So EH10 is one topic, event hub test 10. This topic has one partition, right? And EH test 5 is another topic which has two partitions, right? So I'm going to have an app called multiple, which subscribes to multiple topics here. An app called single topic, which basically subscribes to only the EH test 5 topic. So, and then I'm going to have one single file called same topic, which basically subscribes to EH test 10 again, right? So initially I'll be running multiple and single topic together. So I've already run a published app just to start publishing to that topic. But what I'm going to be doing is I'm going to be running an app ID with an app ID node subscriber, an app for 3000. I'm just going to be running the app called multiple.js, which subscribes to two different topics, right? And in that, you can see that this is running. So that is fine. And then I'm going to start another Dapr D instance with the same app ID node subscriber to show that we are still having the same consumer group. And I'm going to basically run the single topic .json. So essentially what's happening here is this app subscribes to EH10 and EH-test5, and this app is going to subscribe to EH-test5 alone. So from here, as I told, I already have a published app running. So what I can do is I can just run Dapr pub/sub and Dapr publish, use the CLI command to basically add to publish events. So the publish app ID is called pub app, and I'm currently having the pub/sub name as pub/sub, and then I'm publishing to the topic EH10 with a data file which just says message type A, right? So if I do that, it's able to publish the event successfully, and this one will basically see that it will be getting the message here, right? Let me just quickly see. It does take some time for that to start, right? EH-test5 is another one. I'm going to send that message also. Okay, just give me 1 minute. Yeah. So if you see here, EH-test5 and EH-test10. So EH-test5, that message is consumed by this consumer and not this consumer. So that is there. And then let's say I'm going to send a message C, which just says message type B. That is apparently consumed by the other consumer for EH-test5. So that's multiple consumers. And since it has two different partitions, each consumer is consuming a different partition, right? And then I'm just going to say, again, EH-test5 is the topic that I'm publishing to. And then I'm just saying test5, test on 5. That is apparently consumed by the first consumer, right? So these are the different ways in which you can have the same consumer ID with connecting to a topic with multiple partitions, and also being able to publish to multiple different topics from a given app. So I'm just using the simplicity of Dapr CLI to publish to multiple different apps, but that can also be enabled through the app itself. Okay. So the other one that I'm going to do is I'm going to change the Dapr consumer name to node subs 2, just a different consumer name. To show that you are also able to subscribe to the same topic with multiple different consumers, which was previously a bug that was not there in the previous event hubs component, but that has been fixed as part of this. So for example, let's say I'm just going to publish to event hub test 10, and as you see, it is already listening on message type A, which was published previously here. If you see in this scenario, it was previously published just in this demo. And then now I can just publish, let's say, message type C, and that will also be received by this consumer. So if you see here, and then again, I can do, let's say, message type B or something. So in this case, what's happening is both the consumers, two different consumers, are consuming from the same topic. Okay. So this is just a simple demo wherein I'm just connecting via the connection string, namespace connection string, and I'm able to publish to different topics. I'm able to subscribe with the same consumer group to different topics, and I'm also able to subscribe with two different consumers to the same topic, right? So let me know if you have any questions. I'm going to stop my share for now.
That was pretty cool, Mukundan. Presumably one of the advantages of this now is because you have multiple consumers on different consumer groups, you can do better scale out. Is that the advantage of this that you couldn't do before?
Yes. So what happened before was, since they were not, since you can't have multiple consumers in the same topic, the main issue was, since you can't have the multiple consumers in the same topic, you can't have, let's say you publish to a given topic and you can't spread it out to different, fan out to different consumers.
Yeah.
So that issue was there as a bug fix. But then the other one is also, since you can have the same consumer group being able to subscribe to this same topic with multiple partitions. In that sense, Event Hub automatically load balances each partition for each consumer group instance app it has. So you can also have a spread for that consumer group also. You can have multiple instances of the same app running at that point, consuming different partitions, right?
Yep, that's pretty cool. Does anyone have any questions that they want to ask? If so, post them in the chat window. If not, we'll have a little bit of time at the end to ask some questions then as well. Outside of that, let's move on. So thank you, Mukundan. Dimitri, can you share your screen, and let's dive in next on talking about the query API that we added to the state store a couple of releases back, and you demoed it then, and now we're going to talk about it on top of Redis.
Yeah. Can you hear me and see my screen?
Yes.
Okay. So yes, I will be demoing my proof of concept for querying Redis state store. And as Mark mentioned, last release, version 1.5, we released query API alpha version, and I added to the slide documentation for how to use and how to the guide to develop to implement this API in a state store component. And in addition to implementation, we also released. In addition to implementation in runtime, we released implementation for MongoDB and Azure Cosmos DB. So in the upcoming release, version 1.6, we are adding implementation of query state API to all the currently supported SDKs. And for the next release, 1.7, we are planning, currently it's still planning, we are planning to support query API for Redis state store. So Redis, by definition, is a very lightweight key value in-memory store, and it does not natively support indexing by secondary keys. And our goal is to manipulate the JSON objects inside this store, meaning that we would like to store, retrieve, and also query the documents. So this is a proposal that I put together, and after looking at different possible solution, I think this one, at least in my opinion, the most viable. And I would like to get feedback from the community. So the idea is to use two models that comes with Redis, one called Redis Search and another called Redis JSON. And these models allow secondary indexing and working with JSON documentation, JSON documents. And this will require some changes, some addition to existing implementation of Redis store. In particular, we would need to specify content type of data, so we could trigger the proper storage procedure. So what are the advantages and disadvantages? So obviously, disadvantage is that the Redis server will need 2 additional models. Another disadvantage is that Redis search requires indexing of the JSON documents before it can run the query. And the third it's a basically implementation detail that Redis search does not support sorting by multiple fields. So we only can search for by one key. For example, in Cosmos DB or in MongoDB, we can have we can search by multiple keys. Advantages. So main advantage that we don't break. With this implementation, we don't break what we currently have in Redis store. So the models are optional. If a user doesn't want to query JSON objects, then it will work without the models because we won't invoke that functionality. The path to indexing schema could be stored in file and passed by metadata to the component, and it's optional metadata. So if we don't have it, then nothing happened. And also, when we store, retrieve, or query, we would need to pass the content type as a metadata, which is also optional. So that's in a nutshell this proposal. And now I can start with demo. Okay, just let me move that out of my windows. So I am using existing Docker image of Redis, which already has these models that I mentioned before. So this is image built by Redis Lab, and the good thing is that this is part of Redis, so it's officially supported models. So it's we can expect further support for the models with maybe even more richer set of features. So let me start that. And now I would like to show you. So since I already have another instance of Redis, I am forwarding the port 6379 from the container to 6378 on the host. And okay, I can minimize that. And this is my Dapr configuration file for Redis. I call it Redis store, and you can see it's it will use localhost port 6378, and it's basically standard Redis component configuration file, except this line where I specify query schema path. And this file will be read by the component, read, parsed, and used for storing for querying the documents. So in this example, I'm using this data set. I have 10 elements, and the key is just running integer from 1 to 10, and the value is a JSON object, which has a nested JSON object for a person containing organization and ID, and it also has city and state. So you can see this is pretty straightforward data set. And I'm using my, I wrote a simple Golang application that uses Dapr Go SDK. And this application knows knows to execute three operations: store data, get object, and query object. So the first I'm calling this command. So Dapr run the directory where I have my Redis config file for Dapr component. This is the name of the application, name of the state store Redis store, and operation set, and input the data set file that I just showed you. So I run with this command, and yes, it's in. So now let's just verify that we have this in Redis. So the second command is I want to get element with ID 9, and let's see. Yes, it's a ID 9, key 9, and you can see that I was able to extract the data. So now I would like to show how this key indexing schema looks like. So like I said, the schema is saved in this file, data/schemas.json. And if you look at this file, I have person org is a string, person ID is an integer, and I have city and state is also strings. And this is how my schema looks like. So this file may contain multiple schemas in case we are storing multiple different type of state. And each schema has a name. In this case, it's user index. And then array of indices. And each index contains 4 attributes. First is JSON path .person.org, and then alias, how we want to address it in the query, type in this text, and if it's sortable, true or false. And we also support numeric values. So for person.person.id, it's numeric, and we have city and state. So and when we run component, this file is parsed and processed by the component. So now I'd like to start querying. So first query is very simple. I want all elements, but I won't just limit the elements, limit the number of elements that I'm receiving. So I'm running this command line. So you can see similar command line. The difference is that the operation is query, and I'm passing this JSON document that contains the query. Okay, and this is the output. So my application is pretty simple. The JSON is the output is a single string, but you can see I have only 5 elements, and they all from the state. What was no, sorry, yeah, it's just all elements, and we want five of them. Let's make this query a little bit complicated. So here I specify filter, and I want retrieve all elements, all documents where the state is California. So this is query 2. And yes, I have 4 entries of 4 employees from the state of California. And you can see I have California, 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 California. Yes, they all from California. Okay, let's make it more complicated. So now I'm using AND predicate, and I want to get all employees from DevOps residing either in California or Washington, and I want the records to be sorted by city in descending order. Okay. Okay, so I have three such employees, and city is Spokane, Seattle, and San Francisco, and indeed the order is descending, and the rest of the query is yeah, we got to try it.
So this is super cool, Dmitry. Just do one more query just to show it, because we have an extra agenda item we've added, and I do want to give time to Long Die on here.
Yeah.
Yeah.
Oh,
and,
yeah.
you know,
So yeah. Okay. So basically, what I want to show is, yeah, we can make this query even more complicated. Like it's or and embedded and and it will work just fine. Yeah. Yeah. Okay. So that's my demo. I would like to get, like I said, I would like to get feedback from the community about the way about this proposal, and if somebody has kind of alternative ideas, I would be glad to hear about that.
Yeah, that was absolutely fabulous. If you haven't tried out the query API, it's really good to try out. We introduced it in the last one. One thing we also noticed inside there, you actually simplified the query API a little bit coming out in the 1.6 release. So there's another thing to look out for. Yeah.
Yes, that's right.
And if anyone wants to implement the query API on any stores that of the many stores that we have, that's another thing that you'd love to see. Implement it on all the other stores we have, the Firebase, the DynamoDB, Cassandra, all of those other ones. So that's always a great first issue if people want to jump in and do that, because the query API is pretty awesome to be able to use on these things.
Okay, yeah, thank you. Thank you, Mark.
Yep, well, fantastic, Dmitry. Well, with that, if there are any questions, please post them in the chat window. I'm going to hand on to Yaron now to pick up on talking about the gRPC componentization and using it, making it pluggable. So, Yaron.
Yeah, hey, can you just make Patrick Huber a co-host also? Because
I will do that.
Yeah,
Patrick, you are now a co-host.
Yeah, awesome. So I'll kick it off, and then we'll have an open discussion. But first, I want to say that the Redis state store querying capabilities do look amazing. You know, I've been always talking about how much we need querying, you know, all across of our state stores, and Redis is one of the most widely used components with Dapr. You know, it's what we install by default for developers to use, and seeing that support there is really great. All right, I'll share my screen, and you will let me know when you can see it.
Yep, we can.
All right. Let me move that and start the slideshow. Okay, hey everyone, my name is Yaron Schneider, Yaron2 on GitHub, and today we're going to talk about pluggable components for Dapr. This issue has been long running in the Dapr community, and before we dive into the nuts and bolts of this, let's talk about what pluggable means. So Dapr is written in Go, and Go basically compiles your code into a single static binary with all of its dependencies compiled into that single binary. So if you have your main function and you have 5 dependencies, they'll all be built into the single binary. For Dapr, the sidecar is called Dapr-D. That's the process that can run on your machine, or it can run in a container. But it's a single binary, and it has all of the Dapr components basically compiled and installed into it once you consume it. So Dapr has over 90 components today. For this simplistic picture, I'm just showing 2, just to simplify things, because inserting 90 boxes in here would be redundant, in my opinion. So this is an example of just the Redis state store and AWS SQS pub sub. But you know, imagine that this goes on to 90 different components, which is a lot. When we talk about pluggable components, we're actually allowing users, you know, to basically say, hey, I want a Dapr-D process that only has the Redis state store, because that's what I'm using. I don't actually need the AWS SQS one. And you can see here that it's sad because it was left out of the party. I'm not picking on AWS specifically. You know, this can be any component that you don't want in your Dapr sidecar. So the whole idea of pluggable components is really to allow Dapr to become this buffet where you basically just use what you want. And the motivation for this is basically split into 3 parts. The main part of it, I think, is smaller binaries to allow Dapr to run in smaller constrained environments like the edge. So Dapr today, you know, I think the binary size is around 87 megabytes. The Docker container image is 26.6, which is really small. But if you want to run Dapr in non-containerized environments where the source code isn't compressed into an image, or you just need service-to-service invocation between your edge devices, and you want it like a less than 10 megabytes binary, running Dapr today won't get you there. And then, of course, there's a smaller potential attack surface if you don't have all of the components compiled into a single binary, because let's say that one of the SDKs or dependencies that Dapr uses was recently, diagnosed with a security threat. So in this model, basically, you avoid that because you only create, or you don't really avoid that, but you lower the chances of encountering that because you only use the components that you need. And then, of course, I think the greatest motivation behind all of this is the ability to use private components. There's lots of Dapr users today, many companies that just want to have their own private components because they have internal systems that they can't contribute components to the upstream Dapr representation. So, think about, you have an API gateway internally in your company and you want to write a Dapr binding to it. You're not going to post that code on GitHub, but you still want to be able to abstract it with Dapr or consume it with Dapr and not have to build your own sidecar. So adding private components today basically means you have to fork the Dapr project, then you need to fork the components contrib repository, which is where we keep our components. So you need to fork those two. You need to write your custom component in Go, and then you need to build a custom Dapr sidecar. So you need to go to the Dapr process, go to the main Go file, import the components contrib version, your version that you have with your custom component. Then you, if you're running in a containerized environment, you need to push it into your own custom registry. And then in your deployment environment, you basically need to configure it to take the new Dapr image. And if you're not running with containers, then whatever orchestration tool you're using, you need to configure that to basically take the process and run it. So it's a pretty convoluted process. But if you're thinking about pluggable components, no matter how they're implemented, what you'd want to see or hope to see is you just need to write the custom component code, and then you can just drop the component into the file system in your environment. So you might compile it into the Docker image that you're running, into an existing Docker image that is extending the base Dapr image, or it's just a file system mount that you provide to your containers or whatever, and that's what you need to do. So you basically don't have this entire process here that really takes its toll, especially on CI/CD pipelines and maintainability. And so the thing that Go gives us, the solution that Go gives us to write custom components is called Go plugins. Unfortunately, it sucks ass. And there are many issues inside of the Go community today with Go plugins. The first of these issues is it requires the use of CGO, which has multiple issues with it, including slow performance. So calling from Go code into CGO or Go plugins, it's much slower than just calling a function that's compiled into your binary, not using CGO. And then you also have cross-compilation issues. Just to drive that point home, I'm going to refer you to a blog post written by Dave Cheney. He's one of the founders of the Go project working on the Go team. And he wrote an article on CGO. And what he chose to open the article with is a quote from a guy named Jeffrey. And the quote goes like this: "Some people, when confronted with a problem, think, I know, I'll use CGO. Now they have two problems." And it's a really good article that really explains the cons of CGO and when did you want to use it. Slower build times, complicated builds, cross-compilation goes out the window. You lose access to tools. Performance will be an issue. It's much slower. An important thing here is C calls the shots, not your code. So Go has this concept of a Go routine, and that's the way to basically synchronize multiple operations that can run in parallel. And Go routines basically are scheduled on top of OS threads. And when you launch a Go routine, you know that you can launch thousands of these and they'll all go on the same OS thread. But with Cgo, you actually get a different behavior that's most of the times not even known to developers, which is, with Cgo, you can't actually have Go routines schedule on top of an OS thread. When you start a Cgo routine, it actually schedules an entire OS thread. And so this becomes a huge concurrency issue in a multi-thread environment. So that's a pretty big issue there. And then, of course, deployments get a lot more complicated. So Cgo has issues, and then, of course, for Dapr, not all of these cons are relevant, or actually they are, but the major pieces of it are, it also requires the same dependencies version for plugins and the host process. This is what the article meant by when saying your toolchain goes out the window. So if your host process is loading a plugin and they're both using the same dependency, they both must use the same version of that dependency. So for example, if your host process and your Go plugin use a JSON library, for example, and your host process uses version 1.1 and your plugin uses version 1.2, you can compile it. You have to make sure that all of them always use the same version. And that's a pretty big problem. And then, of course, it just doesn't work on Windows, which, requires you to, us in Dapr, as Dapr maintainers, to have very complicated CI/CD builds. And what we're basically telling Windows developers is, well, you can't use any of the Go plugins. All of the custom Dapr components that are being written, you can't use those. That's not very inclusive. So HashiCorp Go plugins, let's talk a bit about them. HashiCorp write most of their products in Go. They're a heavily Go dependent company, and they need extensions for most of their products. They chose not to use Go plugins because of the reasons I've shown earlier, and they actually wrote their own Go plugin project, which is here. You can access it with HashiCorp /go-plugin. And this basically allows you to use Go plugins over RPC. So of course, this has a performance penalty, but it's really simple and nice. And the nice thing about this is it takes care of the entire life cycle of the plugin. So because the plugin is essentially like a server, and it can work either with gRPC or RPC. If it crashes or anything else, then their system basically makes sure that it's resilient to errors and failures and whatnot. It has built-in logging. It has syncing with the standard input, standard output of the host process, which is really important. It does support protocol versioning. It has bidirectional communication, which is great. You can implement your plugins just as Go interface implementations, meaning you don't have to write them as proto files. And they're also cryptographically secure plugins, which is important. When you're running processes, they're not compiled into your main library. You want some way to ensure that what you're running is actually what you expect. And this is done with an expected checksum configuration. And they can also be used across TLS. So for example, if you wanted to use them outside of the local network loopback interface, for example, if you want to run them outside of localhost, you could enable them with TLS. I don't think we'll do that in Dapr. That remains to be seen, but it is possible. And so this is pretty good and pretty promising. HashiCorp used this on a lot of their products. It's battle tested, and according to them, it has high performance. That of course needs to be tested and seen. But obviously, using this will have slower performance than using something like Go plugins. But then again, maybe, because Cgo does have a pretty big performance penalty. So it might just be that the performance overhead isn't so critical, actually. But further tests are needed for that. And so in that scenario, if we're using that kind of architecture, what we can see is we have the Dapr process on the right here with, in this case, let's say it's just the Redis and AWS SQS pub subcomponents here. See, I included it, so I don't have anything against AWS SQS. think it's an awesome service. And then if some company or user wants their own custom state stores, this is basically just a binary that's being just dropped inside of the file system, and it communicates with either gRPC or just netRPC with a Dapr process, and it could be cryptographically signed and versioned. And this is essentially just a Go plugin. Now, before I open it up to questions and others, I want to thank many Dapr community members. So Phil Cady, Patrick Huber, and Johnny Collins, who have been driving the discussion for these things. The original issue, if you want to read about it, is called Enable gRPC-based Components. This is the issue 3513, opened by Eddie. Thank you, Eddie. Been upvoted by a few members of the community. All of the benefits that I discussed and more are written in here. We started this discussion, and then it sort of like drifted into a proposal from Johnny that occurred a month earlier, I think, about external gRPC state stores. And Patrick actually took the HashiCorp repository and project into a POC that he did, and he created a really awesome proof of concept that basically implements, I think, if I'm not mistaken, a Dapr state store using this plugin. And yeah, so the discussion is now continuing. It really picked up in the last few days. Patrick, do you have anything to add here, or do you want to show some of the code?
Yeah, I can show the code. I mean, you're spot on, right? And I tried to draw, kind of conceptually what I was thinking about the architecture in that diagram. But yeah, let me share my screen real quick, and I can just go over. I'm not running it in Dapr yet. This is kind of my first Dapr jump, so I just wanted to get some local unit tests working. So let me share this real quick. So what I did was I grabbed the components contrib, and I went into the state, and I added a new component called plugin. And in here, I wrote some code that imported the Go plugin and wrote documentation about how I'm kind of thinking about the component and what things were needed in order to generate the actual Go shared component the interface for the plugin, for the state store plugin. So, following this, you can regenerate these proxies basically, and just kind of go over the code that's in here. So there's a test file that I'm using to run the different fixture tests. Then there's a context file that just contains the information about the plugin and how to discover the plugin. So they're loaded from the file system, and they're just processes. The Go plugin takes handle of starting those up, but there's a convention here that's used in order to load them from certain directories, and that's based off how HashiCorp implements that. So if you go to Go plugin, it's not going to have a loading or binary organization or anything like that. It just uses a convention. And if you go download any Terraform module or Terraform plugin, sorry, you'll see how it handles that. So that's what's stored in here. They have a logging system. Dapr has a logging system. So I was trying to write a log adapter for that. I still have to try to get this to work. It doesn't work great. The host is really what starts everything up. This is kind of equivalent to any of these other main Go files. So this is what starts up and calls into the plugin. And it just wraps the state store and passes information. So one of the big things I saw and one of the issues was filtering out metadata and stuff like that. The metadata are prefixed with plugin dot. So those all get stripped out before they get passed to the child component. And all it's doing is using gRPC to just forward requests basically. So if you're, I'll go into each of the plugins. I wrote 3 so far. I was trying to do a bunch of different languages. I might do .NET next, but we'll see. In here, we've got a gRPC client, a gRPC server, RPC client, and RPC server. So it supports all those 2 protocols. When you write a plugin, you're writing a server component. All these server components do is the client part is what the Dapr process will be using, Dapr will be using to set up the connection, and it talks through this and ends up getting passed to the server component. It's kind of hard to see, but there's a different interface here. So you've got the context package being used, and in the client, it's more of a traditional state store implementation, right? So all we're doing here is mapping one request to a second one, and then taking the response and unwrapping it. So that's the main part. Like, this stuff could probably be pulled up. The plugin context is reusable, and I already started coding some of the other component types in there just to kind of play around with what might be possible. So, you know, the diagram that I put in the issue has a potential like reference architecture where we probably would have like broken out SDKs for each language that have these proxies already created and generated so that users don't have to do it themselves, and maybe has the proto files in there as well. There still needs to be some work on like how that's organized, but for the most part, you would see this stuff get pushed up a little bit so it's easier to reference. And then, so proto directory, this is where the generation happens for the Go stuff. And it generates 2 files. And if you need to regenerate those proto files, there's instructions in here for, you just run go generate. And this gen file here has the proto C command in it to regenerate it. And then fixtures, this is the interesting stuff. So these bottom 2 are not implemented yet. The easy ones were the Go memory and the Python memory, and all these are just in-memory state stores. The Go memory one just uses a map and it's stateful. So you fire this thing up, it spins up a process and it stays running as a server. So if you write memory to it, it'll stay up and continue to serve that memory. It's not thread safe or anything like that. It's just meant to be a demo. And then it just logs the information out that it was called. Still have to see if all of the logging is working. Like I said, there's 2 different logging libraries, and the Go Dash plugin from HashiCorp says that if you have the same HC log library on both sides, it'll work properly. Probably have to do some tweaking to figure out exactly how to get that log adapter to work properly. But when I was running the unit test, I was able to see like failures and stuff like that from system error. So that's good. And there's a README file for this, and then I compiled it. So you have to compile this in order to get it to work. But once you compile it once, then it should be up and running. And then node memory is just a Node.js application. This is not my primary language, so it's probably awful, but it works. So this just calls gRPC JS, and it took me a while to figure this one out. And I wrote a bunch of notes about it, but there's a lot of different libraries that do gRPC. There's a gRPC library, and then there's an @gRPC library. So that took the longest time to figure out how to generate the proto files, but I documented that here on how to like regenerate and run this npx tool. This is the only command I could get to work. Most languages have some sort of like build file that you can run that will regenerate the proxies. Luckily, we would only have to do this like one time. And this one does the same thing. So it's got a data object right here, and you write to it. So the init doesn't do anything but just reinitialize it. And then get will write to it, get will read from it, and set will write from it, write to it, and then deletes obviously. Everybody knows how this works. Ping just says it was pinged. And then there's some setup. This one here, there's a health check that I noticed in the HashiCorp documentation. I don't know if you can see this. Let me make sure that I'm, can you see my browser, or is it not sharing it?
It's not sharing it.
Okay, let me go back here and just share my screen. Okay, so, and let me minimize Zoom here. All right, let's move that out of the way. All right, so there's a guide for plugin write non-Go. So this goes through how to actually implement it, and they use a state service, so that made it really easy to translate these examples into the project. One thing that they have here is the add the gRPC health checking service. I didn't do that from the node project yet. So if you don't do this, it can add some instability to the project. So that's just something to keep in mind for people that are implementing these. And a lot of this stuff would just go into an SDK. So an SDK for Node would have all of this set up, and all you would have to do is implement the interface, like I did in the example here. And as long as you're consuming from that SDK, you should be fine. Let's see. And then finally, there's a Python one. So these files are named with that convention I was talking about, by the way. So the reason that there's some like duplication in the way, like the word state and stuff like that, is just because of the convention. I wanted to make sure that it was dropped in the proper folder, but that can all be changed. And when you look through that document, this is the special format. So how these plugins work is that they start up and then they write immediately this message that the calling process picks up on and then uses it to call back. So you're starting the plugin up as a process, but you don't know what the port is because it's usually random. You can specify the port if you want to, but that just makes it a little bit harder to, like, what if you want to spin up 2 of them or something like that, right? So you specify the port in here and then echo this back, and then the consuming process reads that and then immediately starts to connect to SD out and SD error and streams those. So that's how it handles the log interchange, but this first message that it sends is not part of that. I don't know what these values mean. It's in here somewhere. Yeah, core protocol version, app protocol version. So like this could be a structure and put in there. And this one does have the health servicer included on it. And so if I ran this unit test a few times, we'll see if the demo aligns with the stars here. So yeah, so all this unit test does is it has the, that's not navigating, there we go. So I just wrote a table test that has each of the plugins, and this is just the metadata that the plugin would receive. And most of this is used for convention. The plugin has a runtime configuration that is used to actually start up the plugin. You pass that in the runtime context. Excuse me. Right here. So we have a new Python, new Node, new Java, and then exec is just basically a binary. Then in the host, it actually maps that to, here it is. Great client. Yeah, right here. So this is where you pass the exec command from Go into the plugin. And so most of this is just boilerplate to get that set up. Excuse me. I don't know if there's anything else in here to show. I was just going to go through and try to implement some more of these, but the same pattern could be applied to any component.
Well, we're pretty much out of time now, actually. So,
Oh, shoot.
yeah, no, well, we're just a couple of minutes past the hour. So it'll be good to kind of wrap this up between the two of you, Jeroen, and
No, I think this is great.
Yeah.
I definitely see us talking about this again in a community call, maybe even the next one. But I really want the discussion to continue on GitHub. So everything that's in chat right now can go to GitHub. I think it's going to be a really interesting direction to take Dapr to. Thanks, Patrick, and also thanks, Johnny, for starting the gRPC external state storage discussion.
yeah, pretty cool stuff.
So what about long day?
So Long, look, yeah, I think at this point, Long, can we schedule you for the 8th of February, which will be a month from now, and do your HTTP middleware then at that point? Would that be okay? Oh, probably I got to make you. Long. Okay, look, I'm presuming you're
Hi.
going to say yes to that, hopefully.
I'm here.
Yeah. Can we put you on the next community call in 1 month's time at the Asia time zone on the 8th of February? Would that be okay? And you'll be.
Yeah, no. This time it's finished.
Oh, you're going to be.
Do we have time for this? In this community call?
How long do you need?
I mean, we can.
Maybe 10 minutes, I think.
This is recorded, so
Yeah,
you know,
okay.
for anyone who can stay, they can stay, and it'll
Okay,
be on the
let's do it.
recording.
Yeah.
Yeah.
Okay, let's do it then. All right, that's fine. We're going to extend this community call to be longer than normal, so you got extra special treat. And let's spend the time doing this. If you can't stay, we can understand totally. Otherwise, please stay on. We will not have our open discussion this time. So we'll have that on our next community call. That will be in 2 weeks' time. But yes, okay, Long, go ahead and let's see your work.
Oh, thanks very much. Yeah, let me share my screen. Sorry.
Yeah, perfect. We can see it.
Yeah, could you see my
Yep.
code?
Yes.
Yes. Oh, okay. Let me share the background first. Now we have a middleware to support users custom this request or response, but this is in the runtime and as the plugin state stores says this is not flexible. So I found a way to use WASM to write middleware, and this support users to use it and support hot reload. Let me share the demo first. Okay, here is Go server. Here is a Go server. This has hello endpoint. This will visit hello. There will return I say hello. Now we start it with Dapr CLI. Then we use Dapr invoke to this. Yeah, I say hello. Yes. But if use CLI, hello. Yes, there is a return expand Redis. If visit with high endpoint, this will return for the other four. But if we use invoke with high, yeah, this returns I say hello. So what it does in the background? We use a configuration for middleware, WASM middleware, and in the components we and WASM file for support pace, WASM file pace, and WASM runtime. So there is a WASM handle the WASM. This is used to redirect the requests from high endpoint to hello endpoint. Then this make request works. Let me say the WASM with the Go. This is easy. Just convert the point to string and do some and replace the string, then return. Then we use the tiny Go to build the hello WASM. Then this we can invoke with high, but with CLI without Dapr this cannot work. Then we test the hot replace. We just can with the lost thing, we changed this WASM, still the hello WASM, then we test. Yeah, now this the WASM will do lost thing, and this still returns 404. Here is the whole demo things. This provide a plugin plug in HTTP middleware with the help of WASM.
Yeah, thanks. And that's very similar to how Envoy does it. So Envoy allows request transformations using WASM filters. And for HTTP middleware, I think actually, WASM works great because WASM itself and also its integration with Go is pretty limited, not just with Go, but with many other languages. But for, taking HTTP contacts, taking HTTP requests, and just extracting data, changing, headers, doing all of that, I think, the ability to load WASM components can actually allow users to write, in multiple languages and be able to transform any sort of operation that's supported by the Dapr middleware.
So one question, does this work over HTTP and gRPC?
You can, so yeah, you can load. We don't have gRPC middlewares today. I mean, we do, but we only use them inside of the runtime. But if we had like external gRPC middlewares, then yeah, you could load a WASM runtime, which would take the gRPC context and change it.
Yeah, I'm just trying to understand the benefits compared to the current middleware components.
Yeah, so the benefits here is that you can just drop code that you yourself wrote. You don't have to write it inside of the Go binary. So you don't have to compile it within Dapr.
So the pluggability.
Yeah. And you can write the WASM plugin in any language that's supported by WASM.
Pretty cool.
Yep.
Does anyone have any questions on that?
Long, do you have the repository public?
Pardon?
Do you have the code public? Is there a repository that people can use?
This is as a local. I will push this today to the public, I think.
All right, put it on Discord, please, so that people can find it.
Yeah.
That'd be awesome.
I will post a PR including this.
Yeah,
Okay.
to also make sure that we are clear around the benefits between the two, because we're going to end up with, we'll actually have two middleware pipelines. And so, we probably would want to be clear about when to use one over the other, as it were, and also, whether we intend to support both going forwards and things like this. So I think there's a bit of a discussion that we just need to have with that, actually.
Yeah. So do we have an issue for that? I don't remember, but Long, if we don't have a GitHub issue, can you please open it?
Of course, let me share. Let me post in the chat.
Okay,
Yeah. Yes.
Wait a minute.
Yeah. It'd just be excellent. Well, while you find out, put that in the chat. One thing I just want to make people aware of is that earlier today, I actually created a Discord community calls channel. We were noticing that we actually have our community calls that we publish as GitHub issues, where you can comment on those and put suggestions in them. But we thought it'd be nice to have a dedicated Discord channel for it as well. So if there are topics you want to cover, discussions you'd like to have, feel free to post in that Discord community call chats channel about things that you'd like to see, topics you'd like to present. Our goal here is to have many more people from the community, like we've had today, come along and present different topics, because that way we can get a variety of different perspectives and things. So please take advantage of that. Okay, and then
yeah, I sent the issue link in the channel.
Okay, yeah. So you've posted that as components contrib issue 1171, yes?
Yeah.
All right. Excellent. All right. Well, with that, we wrap up this community call. I want to thank all of our presenters for presenting across a variety of different topics. Next community call will be in 2 weeks' time. At that time, we'll be close to, or maybe be close to shipping the next release, which is the 1.6 release. So I'm sure we'll touch on a number of different topics that'll be in that particular release about what you'll see inside that. You know, for example, we saw some of the query stuff today, API, that'll be a little bit hosted inside there, but there are many other sort of features and capabilities coming in that release. So that will probably be primarily focused on that. Outside of that, I want to say thank you to everyone today and see you in 2 weeks' time.
Thanks a lot. Bye.
Thanks, everyone. Bye-bye.
Thank you. Thank you. Bye.